Good afternoon. In today's session, we are supposed to study about the three-phase induction motor. This type of motor is called as a AC motor, or we can say it is an electromechanical machine which converts AC electrical energy into a mechanical energy. That type of a device we can call as a AC motor, or we can say this type of motor as a induction motor, because here we are using the electrical energy and we are converting that electrical energy in the form of mechanical energy. So there are two types of induction motor, single phase and the three-phase induction motor. In our syllabus, we are supposed to study about the three-phase induction motor, because if you see, three-phase AC induction motor are widely used in industrial as well as in the commercial applications. So this type of motor will not require any type of starting device. It will generate the EMF that it will require to rotate. It means what? That type of motor does not depend on any other starting device. Hence, we can call three-phase induction motor as a self-starting induction motor, because it is generating the EMF. There is no need of other any starting machine. It will generate the EMF. That's why we can say three-phase induction motor as a self-starting induction motor. If you see, there are lots of advantages induction motor is having over the DC motor, because its cost is low, it requires less maintenance, it is simple in construction. If you see, it is reliable, it is self-starting, it will not require any starting device. Here, the less armature reaction and the brush sparking because of the absence of the commutator and the brushes. Because if you see the construction for the DC motor at that time, with armature conductor, armature core, armature winding, we were using the commutator and brushes. So because of that, there are chances of the sparking, but here we are not using the commutator and brushes. That's why there is very less chances of the spark. So these are some advantages over the DC motor. If you see, there are some disadvantages also for the induction motor, like its speed decreases with increase in load. If we are increasing the load at the output, its speed will get decreased. Again, if you see, its starting torque is very less, because here we are not giving any starting device. We are calling three-phase induction motor as a self-starting induction motor. It will create the EMF. So here starting torque is very less. If you see its efficiency which change in the load. And we are saying here the value of speed will decreases with increase on load. But what we are saying, if our speed is decreases, just because of that reason, efficiency will also change. So this is also the disadvantage for the induction motor, like its efficiency changes with change in the speed. Then we have seen the constructions of the three-phase induction motor. Three-phase induction motor will also consist of rotor and the stator. So in our today's session, we are supposed to study about the three-phase induction motor. For that, we are supposed to see its construction, rotating magnetic field, its working principle, slip and torque. These are the terms we are supposed to study with respect to the three-phase, because there are different types of the three-phase induction motor, like spiral gauge, there is slip ring induction motor. So we are supposed to study the relation between slip and the torque. We are supposed to study about the power flow, starter, speed control methods, which we have seen in DC motor also. So here also we will see the speed control method. Then we will see the some application. So here, what we are saying? We are saying we are using the three-phase induction motor, because these motor we can use in industry and we can use also in the commercial applications also. So here, if you see, three-phase induction motor is most common and frequently encountered machine in the industry, because it is having very simple design, its cost is less. If you see, its construction is rugged, its price less, it's easy maintenance. If you see, it is having lots of advantages over compared with the DC motor, because if you see, it's higher power with respect to weight ratio as compared to the DC motor. Also, its cost is low, so lower cost with respect to the power. Its speed is frequently dependent. run easily at a constant speed from 0 to full load. Wide range of power rating, it will have the horsepower that will up to 10 megawatt. So it will have higher amount of fractional horsepower. So if you see, it will not easy to vary variable speed control. It will require variable frequency power electronic drive for optimal speed control. So here we can see about the three-phase induction motor. It can be a part of pump or a fan, or we can connect it to some other form of mechanical equipment. You can take any type of. You can take mixer, conveyor, winder. What we are supposed to do? Here we are supposed to use electrical energy. That will be AC. And we are supposed to convert that electrical energy into the mechanical form. At the output, you will get any energy, but that will be in the form of mechanical. That will be light, that will be air, that will be in the form of heat, any form. So here, if you see, these are some examples which we can use as the induction motor. So these are winder, pump, conveyor, the DC motor, AC motor. We can use these to convert AC supply, that will be the AC electrical energy, into the mechanical energy. So here, if you see, there are different types of the three-phase induction motor. These are nothing but squirrel cage and the slip ring induction motor. We have joined the class. Proceed. Please mute yourself. Okay. So we are using the three-phase induction motor. We can say electrical motor is an electromechanical device because it is converting electrical energy into a mechanical. But here we are taking the AC electrical energy. If you see, we are using three-phase induction motor widely because it does not require additional starting device. We can call this type of motor as a self-starting induction motor. So here, if you see, three-phase induction motor will also consist of two major parts. These are nothing but the stator and rotor. But here, we are not using the commutator and brushes. So there are very less chances of the sparkle. So this is the advantages of the induction motor over a DC motor. So here we are saying we can use the stator and the rotor. So the stator of three-phase induction motor we can made by using the number of slots to construct the three-phase winding circuit, which we can connect with the three-phase supply, and that will be AC, because here we are supposed to study about the AC motor, and in our syllabus we are supposed to study about three-phase. So here we can take three-phase AC supply as a input. So if we are connecting our winding in such a manner where we will get the three-phase AC supply, at that time they will produce the one rotating magnetic field. When we switch on three-phase AC supply, here the magnetic field will get produced. So here, what we are saying, we are making the three-phase induction motor by using three-phase rotor and three-phase stator. So here, what about the rotor? The rotor of three-phase induction motor will also consist of cylindrical laminated core with the parallel slot, as we have seen in the DC motor, which will carry the conductor. The same concept for the armature. But what will happen? The conductors are heavy copper, or we can take as the aluminum bar, which will fitted in each slot and shorted circuit by end ring. So the slots are not exactly made parallel to the axis of shaft, but these are slotted little square. Because of this arrangement, it will reduces the noise and it will avoid the stalling of motor. So here we can say three-phase induction motor will also consist of stator and the rotor. But here there is no need of any type of self-starting device. So there is no need of external starting device. So we can say three-phase induction motor as a self-starting machine. If you see, there are different types of the induction motor. Like one type we can say as a slip ring, or we can say the wound induction motor. If you see this type of motor, we are saying as a slip ring induction motor. So The slip ring induction motor has the stator, the same which will have in the squirrel cage also. But here the rotor will carry the star or delta winding because we are giving the name here, the slip ring. So here if you see, you will give the rotor which will carry star or delta. Star or delta. Kapil, please meet yourself. What we are studying here, we are studying here about the three-phase induction motor. So here we are supposed to give three-phase supply. That will be the AC. But here, when we are using the three-phase supply, we can give in the two connections. We can give in the star or the delta. I have explained in the previous session. What is meant by star? If we are having the three phases, if we are connecting one end of these three phases combinedly, and remaining 3 point we are giving directly to that induction motor, at that time we can say that type of supply as a star supply, star three phase supply. Otherwise, if we are connecting one end of phase with other end of phase, again we are connecting that other end of that phase to the first end of the first phase. If you are making a triangle for that three phase, at that time मतलब एक फेज का पॉइंट दूसरे को कनेक्ट किया है, दूसरे का तीसरे को कनेक्ट किया, इन दैट वे you are making the triangle. At that time you can say that type of phase as a delta connection. So here when we are supposed to study about the slip ring induction motor, at that time you can say here the rotor will carry star or delta winding similar to the stator winding. And here rotor will consist of number of slots and rotor winding are placed inside this slot. So there will be some air gap between the stator and the rotor for the cooling purpose. So the three terminals are connected. How we can connect it? Which will form the star connection. So here three-phase slip ring induction motor consists of the slip ring which will be connected to the same shaft as that of the rotor. Here only we are supposed to see how we are connecting. If you see here, this is the neutral point, and these are the three phases. We are taking one point commonly. That's why we can say this type of motor as a three-phase induction motor, because here we are taking the three end terminal connecting together, which will form the star connection. So here this three-phase slip ring induction motor will consist of the slip ring that is connected on the same shaft as that of the rotor, and it has so what we are saying, it has a set of winding on the rotor which are not short circuit, but we can take it as terminated to the set of slip ring. So here we can connect at the end, we can connect here external resistance can be added through the slip ring. So it will be possible to get higher slip and the pull out torque at the lower speed. Because what we are saying, when we are supposed to use the slip ring, that will be the three-phase induction motor. At that time, what we are saying, we are saying its speed will decreases with increase in load. So here we are supposed to increase the value of slip that will allow pull out the torque at the lower speed. So you will get higher torque at the lower speed also, and the brushes are used to carry the electric current which will take the current and which will give the current to the rotor winding. Again, what we are seeing here, if you see, we are using here three-phase supply. Here we are using the three-phase supply. We are taking one terminal common of these three phases. So it will have some disadvantages, like due to the presence of slip ring and the brushes, its circuit will become somewhat complicated. Here we are using the slip ring, here we are using the brushes, so its construction becomes complicated. It is less used as compared to the squirrel cage induction motor. Slip ring and the brushes assembly need regular maintenance. These slip rings will require regular maintenance. So this will also the disadvantage. If you see, if the rotor winding are shorted, motor is converted to the standard induction motor, and which will have very low torque as equal to the 60%. So these are the some disadvantages. Also, it is having the some advantages over the squirrel cage induction motor. So what we are saying, it is having high starting torque and low starting current. Additional resistance can be added to control the speed, because we are saying speed will decreases with increase in load. So what we can do, we can take additional resistance that can be added to control the speed, and this type of motor is ideal for very high inertia load. If you see for the applications, slip ring induction motor we can use where we will require high starting torque, because as compared to the squirrel cage, यहाँ पे स्टार्टिंग टॉर्क का वैल्यू ज़्यादा होता है. सो वेयर वी विल रिक्वायर द हाइयर स्टार्टिंग टॉर्क, एट दैट टाइम यू कैन यूज स्लीप रिंग इंडक्शन मोटर. यू कैन टेक एग्जाम्पल एज एलिवेटर्स विच वी आर यूजिंग इन द मॉल. मॉल में जो एलिवेटर से हम ऊपर से नीचे जाते हैं, नीचे से ऊपर जाते हैं, वी आर यूजिंग द इलेक्ट्रॉनिक एलिवेटर. सो इन दैट वी कैन यूज द slip ring induction motor. Again, if you see, we can use in the printing presses, compressor, conveyor belt, hoist, we can use slip ring induction motor. If you see the construction for induction motor, it will consist of two types, two parts. These are nothing but rotor and the stator. The outer, you see the blue, we are saying this is as a stator, and inside we are saying this is the armature winding, that will be the rotor. So here we have seen the one type, that is nothing but the slip ring induction motor, or we can say wound rotor induction motor. Another type is nothing but the squirrel cage induction motor. This is the type of induction motor we can say as a squirrel cage induction motor. So this is also the type of three-phase induction motor, which will be look like a, if you see, this will look like a cylindrical in shape. It has slots on its periphery. If you see, it is having the slots on its periphery. So the slots are not parallel to each other, but they are bit skewed. These are connected with each other. So skewing will prevent the magnetic locking between the stator and the rotor. So here we can see we can use the squirrel cage induction motor where we will require very less torque, when we will require less starting torque. At that time we can use this cylindrical type induction motor, which we can call as a squirrel cage induction motor, because here we are using the squirrel cage rotor, which will consist of aluminum or the copper bar. These are nothing but these are the good conductors. So here the working of motor is improved and it will have low noise. Its noise is very less. So here these bars, when we are using the rotor, which will be of aluminum or the copper, at that time these are called as the rotor conductor, and we can place these in the slots of the periphery of the rotor. If you see rotor conductor, these are the squirrel gauge conductors, are the permanently shorted by copper or aluminum ring. That's why we can call this as a end ring. Squirrel gauge rotor, we can say this as a end ring because these are permanently shorted by the copper. If you see, they form a complete closed circuit which will look like a cage, because they are making the cylindrical structure which is looking like a cage. That's why we are giving the name here squirrel cage induction motor. And here rotor winding is also symmetrical, as the bars are permanently shorted by the end. It is not possible to add external resistor, but in the slip ring, what we have seen, we can control the speed by adding the extra resistor, but in the squirrel cage induction motor, it is not possible to add the extra resistance. Here there is absence of the slip ring, but there we were using the slip ring. So here, as we are not using the slip ring and the brushes, its construction will become very simple and robust as compared to the slip ring induction motor. That's why this type of induction motor is widely used. If you see the advantages of the squirrel gauge induction, its construction is very simple because here we are not using the slip ring. As there are no brushes, there are very less chances of the sparking and it will require very less maintenance. But in slipring, we will require higher amount of the maintenance. So these are some advantages of the induction motor. If you see for the applications, squirrel gauge induction motor we can use in the drilling machine, fan, printing machine. In lattice, we can use squirrel gauge induction motor. If you see the cut view of the squirrel gauge induction motor, it will look like this. Here, if you see, we are putting some gap in between the stator and the rotor for the cooling purpose. So, air will come here. Here we can use the fan for the cooling purpose and to decrease the heat because as motor will rotate, there will be power dissipation in the form of heat. So we can use their fan also. So here I have shown the axial view of the stator and the rotor winding. What we are saying? We can say three-phase induction motor will consist of main two parts. These are nothing but stator and the rotor. But in stator, what the concept will come? We can say the induction motor will consist of the stator in which there is a stator frame, the outer covering. Outer covering we can say as a stator frame. We are using the stator core in order to reduce the eddy current losses. We are using the stator core which will laminate it. Here after that we are using the stator winding in the slots. You can see here. After that we are using the stator winding. The slots on the periphery of stator of three-phase induction motor carries the three-phase winding. So this three-phase winding is supplied by three-phase supply, that will be star or the delta. So the three phases of winding connected either in star or delta depending upon which type of starting method we are supposed to use. So the winding wound on a stator is also, we can call this winding as the field winding because stator winding is nothing but which will remain constant, which will not rotate, only it is doing the work. So we can say this type of winding as a field winding. So when we are giving the stator with the three-phase supply, at that time it will make rotating magnetic field which will rotate at the synchronous speed. What after that we can see here when we are supposed to use the three-phase induction motor, at that time it will consist of stator, stator frame, stator core, stator winding and the rotor. In rotor, what we are doing? Rotor is nothing but it is the rotating part of the induction motor which is placed in the concentric way in the stator. It is placed inside the stator. The rotor is made up of thin steel lamination with the slots for rotor conductor along the periphery. It means what? Here we can use aluminium or copper which will be a good conductor in the slots and they are shorted by the end ring. The slot rings are not exactly made parallel to the axis of shock but these are slotted. So here when we are using the three-phase induction motor, at that time we are using the rotor that is nothing but rotor winding, or we can say this is as a main winding, or we can say this type of winding as a armature winding which will rotate, and at the output we can connect the load. So here if you see the rotor of three-phase induction motor are differentiated into two types. These are nothing but spiral gauge rotor or the slip ring rotor. In slip ring, we are supposed to use slip ring. And again, there is one main point. When we will require higher starting torque, at that time we can use slip ring induction motor, in which we are using the slip ring induction rotor. Again, we are saying there is another type. This is nothing but squirrel gauge induction motor. So in squirrel gauge induction motor, we can use squirrel gauge rotor where we will require less starting torque and where there is no need to use the slip ring. If you see its construction is very simple as compared to the slip ring induction motor, it will require very less maintenance because here we are not using the brushes and the commutator. So it will require very less maintenance. If you see the differences between the slip ring and the squirrel cage induction motor, about the slip ring induction motor, you can say its construction will be very complicated because of presence of brushes and the commutator. About squirrel cage, you can say its construction is very simple because there is no need of the brushes and the commutator. If you see for the another difference in the slip ring or the we can say wound induction motor, the rotor winding is same as that of the stator winding. But in the squirrel cage, rotor will consist of the rotor bar which are permanently shorted with the help of end ring. So this is again another difference. If you see external resistance, we can add in the slip ring induction motor to increase them, to control the speed. But in the squirrel cage induction motor, we cannot. Please, Rohit, mute yourself. टीवी देखते देखते तुम लेक्चर भी अटेंड कर रहे हो.
हिला पाहून मनात कसं तरी होतंय.
Rohit, I will not tolerate this. Huh? Okay. Huh. All these lectures are going for you. And if you are disturbing the class, what is the use of that class? Na? Okay. Huh. So, remaining students, please focus on this. What we are saying, when we are supposed to differentiate between the squirrel cage induction motor and the slip ring induction motor, because in our syllabus we are supposed to study about the three-phase induction motor. In that we are supposed to study two types. These are nothing but the slip ring induction motor and the squirrel cage. If you see in squirrel cage, construction is very simple because we are not using the commutator brushes. But if you see for the slip ring, there will be higher amount of starting torque. Also, we can add external resistance in the slip ring to adjust the value of speed. But in the squirrel cage induction motor, there is not possibility to add the external resistance. So these are the some differences between squirrel cage and the slip ring. Also, if you see as compared to the slip ring, there will be less rotor copper losses in the squirrel cage induction motor. Rishikesh.
Yes, ma'am.
Please mute yourself.
I'm on mute.
Okay. What we are saying again, if you see for the maintenance as compared to the slip ring induction motor, here we are not using the brushes, we are not using the commutator, we are not adding the extra resistor. So here it will require less maintenance in the squirrel cage induction motor as compared to the slip ring induction motor. So these are some differences between the slip ring induction motor and the squirrel cage induction motor. What we are saying about the construction of three-phase induction motor, we are saying three-phase induction motor will consist of two main parts. These are nothing but stator and rotor. So first part will be a stationary stator. If you see, we can say this as a outer frame, stator frame, or we can say this will be worked as a yoke. It will give the protection. It will give the protection mechanical support to the assembly of the AC motor or the three-phase induction motor. So we can see this will look like a cylindrical structure, and the outer covering we are saying as a stator frame. Stator we can made by using the several thin laminations of the aluminium or the cast iron. They are punched together to form a hollow cylinder. So it will look like a cylindrical in shape. Here we are taking the coils. These are insulated wire which are inserted into the slots. And stator of three-phase induction motor we can make by using the number of slots. So each group of coil together through a power, it will surround and it will give us the application of the AC supply, because when we are giving the AC supply at that time, the number of pole of the induction motor will depend on the internal connections of that stator winding, how it is connected. And what we are saying, The stator of motor consists of overlapping winding and it will consist with the overlapping winding with electrical phase shift that will be of 120 degree. So the stator of three-phase induction motor will consist of main three parts because it is consists of the overlapping winding with the electrical phase shift of 120 degree. So that will be the stator frame, stator core and the stator winding. So here, if you see, I have shown what part we are saying as a stator winding. This, which will look like a tar-like structure. We are saying this as a winding. What we are using here? We are using the stator outer covering that we can make by using the any material. That will be the laminated. After that, we are using the stator core. At the stator core, we can use iron. We can use the iron as a stator. If you see, this is the view how we are using the stator in the three-phase induction motor. That will be the squirrel cage and that will be the slip ring, because stator will not change. Stator will remain same in both. So here, when we are using the stator at that time, stator frame is the outermost covering. This is the outermost covering of the three-phase induction motor, which will work as covering and which will give protection and mechanical strain to all the internal part of the stator. It is give the mechanical support to all the internal parts. And the frame is either we can make by using the steel or we can use the die cast. The frame of three-phase induction motor will be very strong and it will be required air gap, because here we are supposed to give some air gap for the cooling purpose, because when the rotor which will be inside the stator will rotate at that time, there will be power dissipation in the form of heat. That's why we will be required there some amount of air gap. After that, we are using the stator core. This is nothing but iron core. So here we can say, in order to reduce the eddy current loss, eddy current is nothing but if there is not proper winding, not proper grounding at that time, if we are not giving the power supply accurately, at that time if the current will flow, we can call that current as eddy current. So here, in order to reduce the eddy current losses, we will require the stator core that will be laminated, and this laminated type of structure we can make by using the stamping. And if you are taking all the stamping together, which will form the stator, if you see here, we are connecting the stamping one to other. So these are combiningly together. These are combiningly together to form the stator core. So the stamping are generally we can do by using the silicon steel, which will reduces the hysteresis loss. And the main function of stator core is nothing but it will carry the alternating magnetic flux, which will require to generate the EMF. That's why we are using here iron core. After that, we are using there the winding. This winding we can say as a stator winding. So the slots on the periphery of the stator core carries three-phase winding, because here we are giving the supply that will be the three-phase. So the three-phase winding we can supply with the three-phase AC supply. So these winding we can connect either in the star connection or in the delta connections. Only we are supposed to give here three-phase supply, and the winding that will be wound on the, on which it is winding, it is wound on the stator. So we can call this winding as the field winding. Now we are supposed to study about the rotor. What we are saying about the rotor? Rotor is the rotating part of the induction motor, which will look like a cylindrical view. If you see, it will look like a cylindrical view. It is made up of several thin steel laminations with the slots for the rotor, which will consist of the conductor along the periphery. And here we are using the bars which are made up of aluminium copper. If you see here, we are using this bar, rotor bar. So we can make that bar by using the aluminium or the copper, which will be the good conductor, which are inserted in these slots. So here they are short circuited by the end ring. If you see at the other end, we are using the end ring. So we can see these are the short circuited by the end ring, and these slots are not exactly made parallel to the axis. If you see, we can see these are the parallel, but if you see here, these are not exactly parallel. So we can say we are using here the slots. These are not exactly parallel to the axis of shaft, but they are look like a little skewed. There is some difference to make these two bar as a parallel. This arrangement will reduces the noise and which will avoid the stalling of motor. So here we can say we can use the rotor and the stator to make the three-phase induction motor. So depending on the two types of the motor rotor, we are having the two types of induction motor. Stator will be remain same. If you see, stator will remain same, but only rotor will get into two parts. These are nothing but it is divided into squirrel cage and it is divided into the slip ring induction motor. So slip ring induction motor will look like this and squirrel cage induction motor will look like this. What we are saying about the squirrel cage, if we are supposed to use three-phase induction motor as a squirrel cage, at that time there is no need of the slip ring. If we will require the small amount of starting torque, we can use squirrel cage. Because its maintenance is less, here we are not using the commutator and brushes, so there is very less chances of sparking. Here we are not using the slip ring. But if you see for the slip ring, here we are supposed to use the slip ring. Here we are supposed to give the supply that will be three phase, that will be star or the delta. Here we will require higher starting torque. So its construction will become somewhat complicated as compared to the squirrel cage. Practically it will look like this, and theoretically if you see, this construction will look like this. Here we are giving the supply that will look like a star. Here we are taking the three phase. We are connecting one point of this three phase commonly, and we are giving to the slip ring induction motor. At the output side, we can connect external resistors to adjust the value of speed. But in the squirrel cage, we cannot add external resistance at the output. So these are the two types of the induction motor in our syllabus we are supposed to study. If you see, practically stator will look like this. And what we are saying about the winding, when we are supposed to give three phase supply. Single phase, we are taking the 360 degree. So if you see here, you can see we are using the three phase, A, B and C. So if you see, there will be the 120 difference between two phases. Respective corresponding two phases, there will be the difference. So here we are using the three phase supply, which we can connect into a star or the delta connections to give that data, to give that supply to the DC motor. When we are giving the three-phase supply, at that time, how this part will rotate, we have just shown there the diagram. This is nothing but, this is the construction of the DC motor, how it will rotate. If it is here, it will rotate to here, it will rotate to here, here. This is, there is a phase difference. If you see, this I have taken as a 60, again 60. So in the phase A and phase B, there is a difference of 120 degree. In phase B and in phase C, there will be difference of 120 degree. Because total we are taking as a, join the class, because instead of single phase we are using here three phase supply. So one phase के लिए हम 360 use करते हैं, तो 360 divided by 3 you will get 120 degrees. So when we are giving the three phase supply to the squirrel cage induction motor or the slip ring induction motor, at that time we are supposed to take three phases that will have 120 phase difference between the respective phases. So here this will rotate, look like this. If anyone is facing any issue, you can ask me.
And that university mock test we have to give the direct second year students.
You have taken admissions right now, na? You are direct second
Yes,
year.
ma'am.
So you have not taken
Yes.
the admission. So how will be the exam for you? There will be exam only for the backlog students.
Okay, okay, ma'am.
Okay.
Thank you.
Okay. If you guys have not finished your assignment, if you have not finished your assignment, then you can submit that assignment. I have shared these assignment questions in the WhatsApp group, as well as I have given that questions in the our classroom also, Google Classroom. So you can submit your assignment. Okay. Now we can conclude our today's session. Thank you. You guys can leave now.